So in this video, I'm going to show you how can you debug and get some relevant information of your sensor connected through the I2C interface, okay? So in this case, I have here a BNO055 sensor by Bosch, and we are going to learn how we can connect its sensor through the I2C interface and how is the process to get started with a sensor into I2C interface, okay? So the first step is just go to the documentation. So you can start with the quick start guide. I think that is a good start point. And then we have here some introduction information about the sensor. And we can see here that there is several operating modes for this sensor. We are going to set up this IMU operating mode. That means that this is a fusion mode because it's combining two signals, the signals from the accelerometer and the signal from the gyroscope, okay? So we are going to set up this operation mode of the sensor. And of course, there is the communication protocols that this sensor supports. We can see here that we can communicate through the sensor using the I2C interface, okay, and the UART as well. So we are going to use this I2C interface to just set up all these parameters of the sensor. Okay, so after we read this quick start guide, we need to go to the datasheet of the sensor. This is the data sheet of this BNO055, okay? And there is here a section for the I2C protocol. And of course, we need two wires, the clock and the data, to communicate through the I2C interface. And there is some several addresses that we are going to have if we connected correctly this sensor to our microcontroller or our microprocessor, okay? So if it's your first contact with this type of sensor, I recommend it use a microprocessor so you can run embedded Linux on that, and you can have access to several I2C utilities for debugging and get some relevant data information from your sensor. So we are going to do that, okay? I'm going to put in the description all the information, so how you can configure your Raspberry Pi to communicate over I2C, and how is the connection between the Raspberry Pi and the sensor and the utilities that you need to install, okay? So now just let's go to the terminal, and we are going to access here the Raspberry Pi. So I have here my Raspberry Pi power on and connected to the I2C interface to my sensor. And the first command that we are going to run is just to run this I2C detect utility, okay? Sorry, it's I2C detect utility. And we are going to list first all the interfaces, all the devices that we have connected into I2C bus. Okay, so now you can see that there is the 29 address. So if we back here to the data sheet, we can see that the default address for this sensor is 29, okay? So that means that the sensor is correctly detected by the Raspberry Pi, okay? And we are ready now to just send commands right on read address from this I2C interface, okay? So the first thing that we can do here is just try to read some raw data from the sensor, okay? So for this reason, we can use here the I2C get utility, okay? Okay, so before we do that, I think that for just reading some route information for the sensor, we can use another utility that is I2C dump, okay? And we are going to list all the registered data and all the route data for this device. So the device is in the address 29, okay. I2C dump, okay, sorry, it actually here is just 1. Okay, so now you can see all the route data from the sensor, okay? So that means that the sensor is correctly connected to the I2C bus in the Raspberry Pi. Just don't care much about for now about this all route data, okay? We are going to go just step by step, okay? But that means that the device is already well connected to this I2C bus, okay? So now we can just try to read some register for this sensor, okay? And for that we can use this I2C get, okay? Okay, so we need to pass here what is the address of the I2C device that we have connected. Okay, so it's 29, and then we need to pass one register to read some data of this sensor. Okay, so if we can go that, we can go to the data sheet, and we can just try to read some register in the register description page. Okay, so let's see that we have to get this chip ID. Okay, and you can see that the chip ID is in the 0 register, okay, in the 0 offset, and the expected value by default is this value here. Okay, so just having this in mind, we are going to read for the 0 address, okay, register address, and then we are going to get the data in binary, and you can see that the output of this operation is A0, that is the same that we can see in the data sheet of the file value, okay? If we need to, for example, read about the file value of the accelerometer chip ID, we can just need to switch to the first bit of this address, and we are going to have this FB that is the expected value for the accelerometer. Okay, so we are checking if the accelerometer, the magnetometer, and the gyroscope sheets are already well detected by the sensor. Okay, so we can do the same. For example, for the magnetometer, okay, so it's 32, that is the expected value, and we can do the same as well for the gyroscope, okay, so the default value is 0F, okay, so that means that the sensor is well connected, and we can access here the chip information of the sensor and the gyroscope, magnetometer, and accelerometer as well. Okay, this is really important because there is many versions of this sensor implementation. Okay, so each implementation is totally different, have different connections, so we need just to check if we have all these features embedded in this sensor. Okay, so that's it for now. In the next video we are going to access and configure the sensor in Fusion Operate mode. Thank you so much.